Okay.
We're going to go just right into example 1. Maybe. Okay. So here I have an inequality that has 2 variables in it. It's got an x and a y. Okay. We need to figure out its solution. So the inequality y is less than or equal to x minus 1 is an example of a linear inequality in 2 variables. It has the same form as a linear equation, but uses an inequality symbol. The solution of a linear inequality in 2 variables is all ordered pairs that make the inequality true. You can plot these ordered pairs on a coordinate plane to understand the solution of the inequality. Okay, when y equals x minus 1, the solution are all points on the red line. Okay, so if I plug in 0 for x, so my x is 0, my x is 0, and I minus 1, what do I get? 0 minus 1. Negative 1. So my point is 0, negative 1. If I plug in 1 for x, what's my y? 0. Yeah. So there's the point 1, 0. If I plug in a 2 for x, what's my y? 1, 1. So 2, 1. Okay, that's when it equals. That is that line. Okay. But they're not asking for when y is equal to x minus 1. We want to know when y is less than x minus 1. Okay, so let's say we plug in a 3. The y value here, so that blue line, is less than or equal to x minus 1 for each x. Okay, now imagine drawing a blue line for every x value. Where am I going to see blue? Okay, where is, let's say, for x is 2, like where is it going to be less than this line? Is it going to be less than here or less than up here? Less than down. Okay, and see how that's going to be that way for like every value? That's where x is going to be less than that line. Or the y is going to be less than that line. And because it's an inequality, there's going to be more options for your answer. So then you think back to when we were solving the simple equations and we had like y equals 8, that's one value. Y is less than 8 gives you lots of values, right? Okay. When we solve inequalities, we're going to get lots of values for our answers too. And instead of graphing them all, or I mean, instead of writing them all down, we're going to graph them. Okay. So let me. Okay. All the blue rays together, so all those lines we just made, form the shaded region down here. The solution of the inequality is all points on the line, called the boundary line, along with the shaded region. Okay. The inequality with y is less than or equal to x minus 1. Well, here on the red line, we know that's where they are equal to each other. And everything down here is where they are less than y. And that kind of makes sense. Okay. Okay. Okay, let's look at this one. What is the solution of the inequality y is greater than x minus 1? Okay, we want to know where things are greater than x minus 1. Okay, so now everything greater is going to be above the line. So we shaded above the line. Okay, but our line here is dashed. The reason our line is dashed is because it didn't say equal to, greater than, or equal to. It just said greater than. Okay, if we find a point exactly on this line, they're equal to each other. And we don't want it to be equal, we want it to be greater than x minus 1. So everything up here would be shaded. And this is just dashed.
This becomes the last group. Or if we did something like this last group, because it was on a line instead, and then if it was greater, and the dots were filled in or something.
Well, yeah, similar to the filled in and open circles. Yep, yep. Okay, so we're gonna write some notes, but I'm gonna put them on the computer so Harley can at least see what's going on. I can send a copy of it, Harley, and then you can copy it in your notebook if you want. Or just glue it in your notebook, whatever.
Okay.
Maybe. Okay. Oops. Maybe. No. 4, 4. Probably just like me. Oh, there it goes. I was just being impatient. Okay. Okay. Solving inequalities with 2 variables. So to solve these, you will graph a line.
Okay.
And shade part of the coordinate plane. If the inequality is greater than or equal to, oops, or less than or equal to, your line will be solid. If the inequality is just plain greater than or less than, your line will be dashed. So to do these, you really don't have to do much calculating. You just have to like follow the rules. Do I have a dashed line? Do I have a solid line? What you will have to do is draw the line though. So that's going to go back to chapter 2 when we drew lines. But you should be able to graph a line like y equals. That's pretty easy to graph.
So do you know on like the homework, are we gonna have to like use the dotted line or straight line?
Mm-hmm. And
Okay.
it will, I'll show you because they'll be similar to, I think it's similar to the examples. Like it'll give you the option to draw a dashed line or to draw a solid line.
Okay.
Okay, and then so if the inequality is greater than or equal to, you shade above the line. If the inequality is less than or equal to, you shade below the line. And sometimes, depending on the slope of the line, it's hard to tell what's above and what's below. Especially if we're close to vertical, it's hard to tell what's above and what's below. So I will show you like a trick to make it easier to determine like, for sure where you shade. You gotta kind of like do those two options, the first thing and the second thing, and that will be your. Okay, I will go back to our thing. So Austin, it's just the opposite. Like,
Okay.
we're gonna go back here and we're gonna look at our next example. Okay. Describe the graph of the solutions of each inequality. We've got y is less than negative 3x plus 5. Okay, looking at your notes, we have a less than. Is that gonna be a dotted line or a solid line? Dotted line. Okay, not a solid line, dotted line. Okay, and we're saying y is less than negative 3x plus 5. So will we shade above or below the line? Below. Yeah, when y is less than, or when the inequality has a less than symbol, you shade below. Okay, how about y is greater than or equal to negative 3x plus 5? Okay, we have a greater than or equal to, so will we have a solid or a dashed line? Solid. And will we shade above or below the line? Above. Okay, and drawing the line is simple. Remember, this is my y-intercept, the 5, and then my slope is negative 3, sorry. So I go down 3 over 1. So that's solving, or drawing should be easy. And then if you follow those rules, figuring out where to shade should be pretty easy also. Okay, so let's say you weren't sure. Let's say you weren't sure where to shade. Okay, but let's use the top one as an example. Y is less than negative 3x plus 5. Okay, and I'm going to do this with one line. Okay, so okay, my line would be negative 3x plus 5. So that would be okay, so this would be where I start. Oh yeah, there would be a point there. And then I go down 3 over 1. This is my line. Okay. My little dash. Oops. Let's start off. Okay. And 3 over 1. Dash 1. Okay. We want to shade below the line, which is that on the left side or is that on the right side? Which do you think would be below?
Yeah.
Okay, well, let's see. Let's plug in a value for x. Let's say x is 1. Okay, what is negative 3 times 1? Plus 5.
2.
2. Okay, we want to know where y is less than 2. It'd be this side. So we would say, yeah. Okay, if you do it on paper, I'm okay with shading like that. Just because otherwise you're trying to shade it on. Doing it on the computer, they will shade it using a color, like a whole color thing for it. Okay. So somebody else is here. I'm guessing that's the computer. Well, good night. Sleep tight. Have good dreams. Really. Okay, so let's look at getting them solved that way. So in order to do this, you need to have y by itself. Okay. So we need to figure out, like, if they give us an inequality where y is not by itself, we need to rearrange it so it is by itself, or we have to write inequalities ourselves in the scoring problem, so y is by itself. Okay, so not Victoria. So the science club sells t-shirts and keychains to raise money. How many t-shirts and keychains would they sell to meet or exceed their goal? So we're gonna have x be the number of t-shirts and y be the number of keychains. The total amount of money they make must be equal or exceed the duration of $500. So writing an equation like this, 10x plus 2y is greater than or equal to 500 is something that you've done before. Done that. T-shirt plus keychains greater than or equal to 500. Okay. Is this written with y by itself? No, y is not by itself. So we need to rewrite it so y is by itself. Okay. So we just solve for y. We pretend like that inequality is an equal sign and solve it in the same manner. So they started by subtracting 10x from both sides and then dividing by 2. So when they finished that, they got y is greater than or equal to negative 5x plus 250. And then they correct it. Right? This would be y-intercept of 250. My slope is x. Okay, does this tell me my line, the greater than or equal to sign? Does that tell me that the line is solid or dead? Solid, because we've got that equal to part. So we've got a solid line. And then because it's greater than, we shade above or below?
Above.
Above. So they shaded right here. That's every possible combination of t-shirts and keychains that would make them $500. Okay, do you want to write all those combinations down? No, I wouldn't want to calculate all of them. This is way. Okay, these are all the possible answers. I'm not going to. Okay, I kind of went over this, but any point in the shaded region or on the boundary is a solution of the inequality. However, since it is not possible to sell a negative number of t-shirts or you must exclude negative values for each. So realistically, only this part is the solution. Because down here, I would have a negative number of keychains, and over here, I'd have a negative number of keychains. So we just use that positive part. So there you can kind of late, but there's a process for solving these, and I will send that home pretty soon. It's just set of rules you have to follow. Okay, using this graph, will the science club meet their goal if they sell 30 t-shirts and 90 keychains? Remember, t-shirts is X, keychains is Y. Okay, so try looking at that, or even in your book if it's a little bit clearer. Will they reach their goal? It has to be on or in the yellow part. On the line or the yellow part. Will they reach 500? Without calculating, like plugging it into the equation. You can say, right, reach their goal. Okay, it's really important to realize how far these are increasing. If you thought this was 90 and 30, oh, yep, it was. But these go up by 40. So this is 120, which means 90 right here. Did they reach their goal? Probably not. They're very, very short. Or very, very close. They're short just a little bit of time. Okay. You can check that by actually plugging the numbers into the inequality and solving them. Those are $10. I don't remember the number. 5. I don't know how much it was. But you could like plug that in and see if it was greater than or less than 500. But more than likely, it looks like they did not. Any questions so far? Okay. You could get started on the homework. Once you see how well, there's two. Do the first 4. For sure. What we have left to do is to be given the graph and then write the inequality. So if you see one where they give you a graph and they want you to write the inequality, we haven't got up to that yet. But you might be able to figure it out. If you really want to. But I'm gonna just show you real quick in the homework what it's gonna look like.
Hold on.
9 problems? What? Oh my goodness. Well, there are 9 problems. Okay, so you can do the first 4. So when they have you graph, they have options over here on the right next to the delete clear button for a solid line or a dash. And so you can draw either solid or dash. And then there is a way to shade underneath with this little paint bucket thing. So paint bucket, I want to shade down here and shade it. I want to shade up top. Oh my goodness. Now it's shaded.
Yeah.
Yeah. So, I mean, you don't have to sit there and like color it all by hand. It'd be much easier to do. There. Okay. Yeah, most of the tools you'll need are over here on the right side. Any questions? Okay, if that is all for today then. Victor, I will record it and send you a link so you can see the first part of the class if you want to. And then there'll also be a page of notes that will go home as well. Otherwise, I hope to see Victor tomorrow and Harley soon.
Oh, I already know I won't be there tomorrow.
Okay,
but
we'll see. We can do class Zoom again. So
you want me to join a Zoom for science?
Today's just a test.
Oh yeah, okay.
Zoom for science. But we can Zoom for and then